This problem is going to give you an answer that's kind of a letdown. Sorry. But up until this point, we've had answers that were numerical and, you know, pretty practical things. And so this would be meters, which I didn't write on the last video, but there we go. This guy ran 96.884 meters, or this would be 25.537 units of whatever, inches, miles, light years, whatever. But this one is not going to give me a numerical answer, and it's a little frustrating. So a curve is defined by the parametric equations, x equals t over a and y equals negative bt, where a and b are constants. What is the length of the curve on the interval from 0 to 1 in terms of a and b? What? Okay, don't make it harder than it is. Our final answer is going to come from this. It's just going to be this. Square root of the derivative of x squared and then the derivative of y squared with respect to t. And so let's find dx dt, which would be, okay, first of all, this is t over a, which is really, and you know this and I know this, but this is 1 over a times t. T is the variable that we are taking the derivative with respect to. Everything else is treated like a constant, because it is. Of course, a is not a constant, it's a vowel. Sorry, couldn't resist. The derivative of 1 over a times t is 1 over a. That joke was so bad, I should just shut the video off right now. The derivative of negative bt would be negative b. That's it. So here we go. The negative b goes here, and 1 over a goes here. And this is my answer, actually. I told you it was kind of lame. I am going to go one step further, though, and you can too. This is the integral from 0 to 1 of, let's see, we'll square that. It gives me 1 squared over a squared, and squaring negative b gives me b squared dt. That's it. That's all I can really do. It's sort of lame. That's all I can do with that square root staring me in the face like it is. I am going to go a little bit further. And final answer in terms of A and B, I could leave it here. Like if it was a multiple choice question, I could leave it here and that might be an answer. But I'm going to do the fundamental theorem of calculus and go a little bit further. So the antiderivative of this, and you might be staring at that thinking, how am I going to take the antiderivative of this? That's a constant. As disgusting as it looks, that is simply a constant. So let's do that. The antiderivative of that with respect to time would be that t. And it's going to go from 0 to 1. So when I said you could stop here or you've done all you can, I didn't mean to say it like that. You can go further. That might be an answer choice is what I'm saying. But let's move on. So if I plugged a 1 in right here, I would have the square root of 1 over a squared plus b squared times 1. And then minus, plug in the 0, and so this is actually it. That is the length of that curve.